Hello everyone, welcome to the channel. In this video we are going to be solving the integral that you see on the screen here. This looks a little more complicated than it actually is, and to be honest, this stumped me the other day, and once I saw the approach that another person took, it just kind of jumped out and slapped me in the face like, oh well, that's pretty easy. So I thought it would be a good integral to make a video over, perhaps to help some of you out there who are getting stuck with integrals like these. So what I'm going to do is I'm just going to solve one of them. I'm not going to solve both at the same time because the steps are all the same until you get down to the evaluation part. And once I get there, I will go ahead and show you the difference between the indefinite integral and the definite integral, okay? So to get started, what we are going to do is we need to make a u-sub. So for our u-sub, we're going to choose u is equal to 3 times square root of x, which is the same as 3 times x to the 1/2. Then we're going to say du dx is equal to 3 over 2 times x to the negative 1/2, which is the same as 3 over 2 times 1 over square root of x. So then we are going to multiply both sides by this dx, okay? And then we're going to move this dx to the other side. So then we have du is equal to 3 over 2 times 1 over square root of x times dx. Now, you'll notice that up here we have a 1 over square root of x here and the dx here in the right place. If you rewrite this integral, you can write it as e to the 3 root x times 1 over square root of x dx. And this right here is what we have right here, okay? So what we're going to do is we're going to isolate that part on our u-sub so we can go back and make this substitution. So we're going to multiply both sides of this by 2/3, and that results in 2/3 du is equal to 1 over square root of x times dx. And now we can go back and we can plug this back into our integral. So let me rewrite the integral again. Let me rewrite it like this. So we have we have e to the 3 times square root of x times 1 over square root of x times dx. I'm only rewriting it so you can see exactly where the u-sub is happening. You don't have to show this many steps when you're working it out yourself. This is just for clarity. So this right here is our u, and this piece is our du, right? So we're going to go ahead and replace those. So we have the integral of e to the u times 2/3 du. Now, if you are doing a definite integral, you need to note that this alpha is an x value and this beta is an x value. And if you're going to change to a u, then you need to use this equation with alpha plugged in for your x and beta plugged in for your x to change your limits of integration. Or you just need to keep track of the fact that you are now in du and your limits are in x, and you need to convert back at the end, which is what I'm going to do in this video, okay? So I'll show you that here in a second. So this integral becomes 2/3 times the integral EU du, because we can move a constant out, okay? Then the integral evaluates to 2/3 EU plus a constant. Now, if we're going to do this with the indefinite, or I'm sorry, the definite integral, then you're going to have, oh, I'm sorry, we're not done yet. I almost messed that up. So we have to go back in and back sub for our u is equal to 3 square root of x. So then we end up with 2/3 e to the 3 square root of x plus c. And that is going to be our final answer for our indefinite integral. Right here. Now, we are going to do the definite one using the limits of alpha to beta. So we're at a, or the limits of alpha to beta of the integral, 2/3 times the integral from alpha to beta of EU du. This evaluates to 2/3 times EU evaluated from alpha to beta. Now remember, these are x values, right? So you cannot evaluate by plugging in your x1 equals alpha, x2 equals beta into this if you don't convert like we were talking about with this equation, right? So what you have to do is you have to change this to 2/3 e to the 3 root x evaluated from alpha to beta. Then that ends up resolving to be 2/3 times e to the 3 root beta minus e to the 3 root alpha. And then that is your final result for the indefinite integral of the limits from a, or alpha to beta, of e to the 3 root x over root x dx. Okay? So if you have a number, all you have to do is plug these numbers in for alpha and beta, and then that is going to be your result. Hope this video was helpful. If you have any questions, comments, or concerns, please feel free to leave it down in the comment section. If you would like me to do a video over a particular integral or derivative from your Calculus 1, Calculus 2, or Calculus 3 classes, feel free to send them to the email that I'm going to provide in the comment section. It's going to say youtube@athen.com or YouTube requests@athen.com. I'm still working on the name for that, but you'll see it in the comments. Just send me a screenshot of the problem you want to see, and I will try to get to it as soon as possible, because I know sometimes these problems are, you need to figure out how to do them for homework or tests or something like that. So feel free to send them, and if it's something that's coming up soon that you need to figure out how to do it now, then I'll try and get on it as soon as possible and get the video out for you. So with that said, I hope this helped, and I'll talk to you soon.